Welcome everyone. So before the start of the video, I would like to request you guys to subscribe to the channel, share the videos, like and write in the comment section what else do you wish to see. This will help me to improve my content. Okay, so in this video we are going to be talking about the activation of alkynes via gold catalysis. Okay, how these alkynes are activated when you add the gold. This I feel this is a very important topic, and there haven't been any question asked on this topic. So in this video I'm going to take up 2 or 3 examples wherein gold catalysis has been used, and I feel there is a high probability of such questions being asked. So now these gold 1 and 3 complexes, okay, they have the ability to interact with the alkyne to form the pi complexes. That is what they do. Once they interact with the alkyne, they form the pi complexes. As a result of this interaction, these alkynes, they become electron deficient in nature. And now once they become electron deficient, now they are susceptible to attack by various kinds of nucleophile. Okay, so what happens when you add water into the media? The attacks take place at the more substituted end, just like mercuration of alkenes and alkynes. So in this case, the result is the formation of the ketone. So let's look at the mechanism, what is exactly happening. So if you have an alkyne and you add the gold 1 catalysis, gold 1 chloride, this is in +1 oxidation state, it interacts with the alkyne, as a result of which it withdraws the electron density towards itself. Now this alkyne now becomes susceptible to be attacked by a nucleophile. So if we have we add a water into the media, so this is what we end up getting. As a result of the tautomerization and the removal of gold plus, we get this, enol, which undergoes tautomerized to give you the more substituted ketone. So this is the product that we end up getting, and this is the exact mechanism. Now, if we see, here we have a 6-membered moiety where we have an alkene and the alkyne. Had we used mercuration condition, means mercuric acetate and water, then we could have been absolutely assured that attack would have occurred on the double bond as well. But here gold is absolutely selective about interaction with the triple bond. Gold does not interact with the double bond, so just keep this thing in mind. Okay, so not to get confused. So what happens now, we can clearly imagine the nucleophile is water and we are doing the reaction in the methanol media. So this simply carries out the hydration of an alkyne to give you the ketone. So this is the product of the reaction. Okay, now let us look at one more important reaction. So this is a very important reaction, but where you have an alkyne and you're taking gold and you have methanol. If we see in the reaction, we do not have any nucleophile. What is the reason for that? Because in substrate in itself, we have 2 nucleophilic sites, that we have the hydroxyl group present in the molecule. So these hydroxyl group function as a nucleophile. So as soon as the gold activation takes place, these OH attacks. So these molecules have internal nucleophile. So similar examples you may come across in the exam. So if we look at the mechanism of the reaction, it is pretty interesting. So what happens in the first step, which we know, the activation of the alkyne takes place with the gold. So gold interacts with the alkyne, as a result of which the lone pair of the internal nucleophile, which is the hydroxyl group present, it attacks to lead to the formation of this particular species. Now what happens? There is a removal of gold plus that take place, and also addition of 2 protons take place, and these protons are coming from the methanol. Okay, and then what do you end up forming is this oxenium ion species. So as soon as, because the lone pair of electrons on nitrogen are coming like this and they are forming CH negative here, that is why 2 hydrogen came to form the methyl here. So now once this protonated species is formed, the other OH of the molecule attacks to release this positive charge to give us this spiroketal moiety. Remember, these molecules are called spiroketal because this is nothing but a spiro moiety. Now let us suppose if I add a strong acid into this media, then what am I going to end up getting? I'm going to end up, there will be a cleavage from this side and there will be a cleavage from this side. So what I'm going to have, I'm going to have a ketone at this particular site. Okay, here I'm going to have ketone and here I'm going to have OH. So this is one of the ways to synthesize these spiroketal moieties. So this was a very important example, and I think that it can be asked in the exam. Okay, so this was all about the activation of alkynes via gold catalysis. Let me know what else do you wish to see. Okay, thank you very much. Have a nice day.